Trig students, lesson 13.9 is going to be over the formulas for tangent. So as you will have noticed, in 13.7 and 13.8 we went over the addition formulas, and then the double angle and half angle formulas for sine and cosine, but we never did anything for tangent. We're going to go ahead and address all of those, the addition, the double angle, and the half angle for tangent, all at the same time here. So hopefully by now you're getting used to recognizing the patterns and whatnot, and we're going to go into all of those patterns for the tangent all at one time, now that you've kind of gotten the hang of that, hopefully. So first off, tangent addition formulas, which will be if we are adding angles or subtracting angles to come up with what we're looking for. If we are adding those angles, it is going to go like this. It is going to go like the tangent of alpha, our first angle, plus the tangent of beta over 1 minus the tangent of alpha times the tangent of beta, or the first angle and the second angle. Okay, so if you're keeping track of the signs, the sign in the numerator will match the sign we have here, and the sign in the denominator will be the opposite of, and that pattern follows over to when we are subtracting. It will be the tangent of alpha minus the tangent of beta over 1 plus the tangent of alpha, or the first angle we have, times the tangent. I don't know why I put 10 there. Tangent of beta. Okay. Now, some books and things will show this all combined and show it like this. When we add or subtract, okay, so what's going to happen is, as we write this, we're going to have the tangent of alpha, and the operation on the top will go with the operation on top over here. So tangent of beta. So what that means is, when I'm adding these angles, I'm adding these angles. And when I'm subtracting these angles, I'm subtracting these angles. Now on the bottom, it will be 1 minus or plus the tangent alpha tangent beta, because if you remember back up here, when we are adding these angles, we actually subtract down here, and when we're subtracting, we add. So the tops stay together, the bottoms stay together. If you want to remember this, or if you'd rather just focus on these individually, either way is fine. Okay, the double angle formula for tangent is pretty simple. It goes like this. It's going to be 2 times the tangent of alpha over 1 minus the tangent squared of alpha. Okay. And lastly, we've got 3 different formulas for the half angle formula for tangent. The first being one of our plus or minus square roots. It will be plus or minus the square root of 1 minus the cosine of theta, over 1 plus the cosine of theta. Okay, so if for some reason we know the cosine, this one would be pretty easy. If for some reason we know the sine and the cosine of theta, then we'll want to look at this next one, which is the sine of theta over 1 plus the cosine of theta. Or sometimes this one might work out the best. 1 minus the cosine of theta over sine theta. Okay, so you've got all three of these options for the tangent half angle. And you'll want to have all these handy, of course, when you're working on your problems. So let's go look at some examples. Simplify to a trig function of a single angle, don't evaluate. So again, this is like the beginning of our last couple assignments where we're simply identifying the pattern. And when I see this pattern right here, it looks very similar, identical to one of my tangent addition formulas. And when I add in the numerator and subtract in the denominator, that is the equivalent of my tangent addition formula where I am adding the values, right? So what takes the place of alpha here? Well, it's 27 degrees. What takes the place of beta? It was 31 degrees. So if I'm writing this as a single angle, I have the tangent of 58 degrees. Okay. And it said don't evaluate. Obviously, this didn't really help us out much, right? We don't know the exact value of this one either. That's fine. All we're doing is working on recognizing these patterns. Okay. So hopefully when you look at this one, you notice that this matches when I take 1 minus the cosine of something divided by the sine of that same something. That matches one of our half angle formulas, and it's tangent of theta over 2, which theta here is 43 over 2. So when I write that as a single angle, I have tangent of 21.5 degrees. Okay. All right. So let's go ahead and find the exact value of a couple problems here. So finding the exact value of the tangent of 165. Well, first I need to establish what values I'm going to use. What am I going to add angles together? Am I going to subtract? Am I going to double an angle or take a half angle? I noticed pretty quickly that I can add a couple angles together here. So this is the equivalent of tangent of 120 plus 45. That's the one I noticed right away, which feeds right into, so we're going to deal with our tangent addition formula, which goes like this. Tangent of my alpha, which is 120. Remember the one in the numerator matches, so plus the tangent of 45 over 1. Remember this sign is the opposite of what I've got there, so minus the tangent 120. And remember that I am multiplying down here, so that minus the tangent of 120 times the tangent of 45. Okay? Now, unlike sine and cosine, our unit circle doesn't necessarily just come out and give us my value of this trig function. Remember, tangent is equal to y over x. So when I'm looking at this, when I'm looking to fill in for tangent 120 and tangent 45, I've actually got to go do a little work first. Okay, so the tangent of 120 is equal to the y value of 120, or the sine, which is root 3 over 2, divided by the x value, which is negative 1/2. And when I go simplify that, I've got root 3 over 2 times negative 2 over 1. So I multiply by the reciprocal. 2's simplify, and I'm left with a negative root 3 over 1, or just negative root 3. Alright, the tangent of 45 degrees is the y value, which is root 2 over 2, root 2 over 2. I should notice that when I take the same thing or something divided by itself, I should end up getting 1. But if you didn't notice that right away and you went to solve this, you would multiply by the reciprocal, and then you would notice that everything simplifies, right? Okay, so that would equal 1. Okay, so now that we know this and we know this, we can plug into our equation. So the tangent of 120 I found to be negative root 3, plus the tangent of 45 I found to be 1. Then I have 1 minus, and the tangent of 120 was negative root 3, times the tangent of 45, which was 1. Now we're going to simplify. So this equals negative root 3 plus 1 over 1 plus root 3. Okay? So mathematically this is correct. You will recall that we have a root in the denominator, so we don't necessarily like to have that. So what that requires is multiplying, if you remember back to some Algebra 2 lessons, is multiplying by its conjugate. So what will allow me to get rid of this root 3 is multiplying by the conjugate of the denominator, which is 1 minus root 3. Okay, so 1 minus root 3. I'm going to go down here, change my color. This is somewhat complicated, so make sure you stay with me. So essentially I have a binomial times a binomial in both the numerator and the denominator. So when I take those and multiply them by one another, on the in the top I'm going to end up with, okay, root 3 times 1, negative root 3 times 1, so I've got negative root 3. Then the outsides I'm going to have negative root 3 times negative root 3, which would be plus 3. The insides I would have a plus 1. And then the last I would have 1 times negative root 3, which would be negative root 3. Multiply the bottom. 1 times 1 is 1. 1 times negative root 3, negative root 3, root 3 times 1, positive root 3, and then root 3 times negative root 3, negative 3. So, these are going to go away, right? So I have a negative something and a positive something, they're gone. So up here I just need to simplify, and I would simplify my constants would add up to 4, and I'm subtracting root 3 twice, so minus 2 root 3. All that would be over 1 minus 3 is negative 2. Okay, so if I were to simplify that all the way down, 4 divided by root 2, or I'm sorry, 4 divided by negative 2 is negative 2. Negative 2 root 3 divided by negative 2 would be a positive 1 root 3, so plus root 3. Okay? So negative 2 plus root 3, or you might rearrange it to be root 3 minus 2. You might see that as an answer as well. Okay. Next one, tangent of 3 pi over 8. Again, you can recognize that this is going to be the tangent here. Okay, I'm back. Had to pause there for a second. So hopefully you recognize that 3 pi over 8 is half of 3 pi over 4. If you didn't recognize that right off the bat, change 3 pi over 8 into degrees. Don't feel bad about doing that. So I know that that is going to be the equivalent of 3 pi over 4 divided by 2. Okay, because 3 pi over 8 is half of 3 pi over 4. Okay, so I'm using the half angle formula, which I know is 1 minus the cosine, or there's a couple different ones I could use, right? I'm going to use this one, 1 minus the cosine of 3 pi over 4, because theta is my 3 pi over 4, right? Over sine of 3 pi over 4. Alright, now there's not going to be, and the reason I use this one is look back here. Okay, I could use any of these half angles. I don't really want to deal with this because I don't want to have to deal with a possibly having to mess with a conjugate. That was messy in the last one. I notice right here I've only got sine in the denominator, so this shouldn't be too difficult. Okay, and this one over here I would have had to mess with a conjugate as well to get rid of a root possibly. So that's why I do what I do here. So I've got this. I'm just going to fill in what I need to here. 1 minus whatever cosine of 3 pi over 4 is, which is negative root 2 over 2. That's my numerator. And sine of 3 pi over 4 is positive root 2 over 2. So now it's just a matter of simplification. That is going to be 1 plus root 2 over 2. Okay, so if I were to get a common denominator, I know that's going to be 2 plus root 2 over 2, and all that's over root 2 over 2. So when I multiply by the reciprocal here, I'm going to have 2 plus root 2 over 2 times the reciprocal of this denominator, which would be 2 over root 2. Ends up being 2 plus root 2 over root 2, because those 2's went away, right? And multiply top and bottom by root 2. Multiply by root 2 over 2 over root 2, sorry. So that's going to equal 2 times root 2 is 2 root 2. Root 2 times root 2 is 2. Root 2 times root 2 is 2. Simplify that. 2 root 2 over 2 would just be root 2. And 2 over 2 is 1. So you really have to have your algebra procedures and your and everything like that down in order to get these the ultimate answer correct. Okay. Lastly, let's look at a few things. If tangent of alpha equals negative 3 over 4, tangent of beta equals 5 over 12, and alpha is a second quadrant angle, let's look for both of these. So, tangent addition formula here, obviously, but I am subtracting. Therefore, that is going to be the tangent of alpha, which it gives me is negative 3/4. And remember, the sign stays the same, so I'm subtracting the tangent of beta, which is 5/12. And that's going to be over 1. Remember, that sign is the opposite. And then I multiply those numbers together, so negative 3/4 times 5/12. Okay. To be quite honest with you, I might just plug this into my calculator and hit enter. If you didn't want to do that, here would be the procedure. Find a common denominator. You're going to realize that that is negative 14 over 12. You multiply across here, you're going to end up with 1 minus 15 over 48. All that's going to simplify to negative 14 over 12 over 33 over 48. And when I take the top times the reciprocal of the bottom, I end up with negative 56 over 33 to simplify. So instead of doing all that, I recommend, and we'll go over this in class if you want to, just how to type that in exactly how you see it into your TI Inspire. Let's go over here and look at the double angle formula. If I know the tangent of these two things, I may as well, or I know the tangent of alpha, I may as well go right here with the double angle formula, which is 2 tangent of alpha over 1 minus tangent squared of alpha. Now it's just a matter of filling in the blanks. So it's going to be 2 times, and the tangent of alpha, they said, is negative 3 over 4 over 1 minus. The tangent of alpha is negative 3 over 4. But I'm going to square that because it was that value squared, right? So, again, you could type that into your calculator, or if you wanted to do it pencil and paper, this would be negative 6 over 4 over 1 minus 9/16. So you've got negative 6 over 4 over, that looks like it would be 7/16, right? So when I'm simplifying, negative 6 over 4, and I multiply by the reciprocal of 16 over 7, and I end up with negative 24 over 7 for a final answer. Again, you could just take this right here, plug it in your calculator, hit enter on the TI Inspire, and it will kick out this fraction for you. In class, we are going to work on 3 through 24 multiples of 3, and 25 through 30 all. We will see you later.